I am Radhakrishna, mathematics teacher. Today we are going to continue our topic definite integrals. Already we have discussed the properties of definite integrals and we solved a few problems. Now we are going to continue the problems on properties of definite integrals. Okay. The first question, integral 0 to 6.5 fractional part of x dx. We know that fractional part of x is periodic function with period t, and the property is if f of x is a periodic function with period t and n is an integer, integral 0 to nt f of x dx is equal to n integral 0 to t f of x dx. Fractional part of x is periodic function with period 1, but this is not in the form of nt. Okay. So, what we do is we first write it as 0 to 6 fractional part of x dx plus 6 to 6.5 fractional part of x dx. Okay. And we can write the upper limit as 6 into 1. Okay. We know that a definite integral can be separated into two integrals. It can be expressed as sum of two or more integrals. Okay. 0 to 6, 6 to 6.5 means its meaning is we are integrating from 0 to 6.5. Now, using this property, it is equal to 6 integral 0 to 1 fractional part of x dx. And here between 6 and 6.5, the fractional part of x will be same as between 0 and 1.5, because the graph of fractional part of x will be like this: 0 to 1, 1 to 2, 2 to 3. In this way, 6 to 7 also it is same as the values between 0 and 1. Okay. So, this is what y is equal to x. So, in the interval 6 to 6.5, the value of fractional part of x is same as integral 0 to 0.5. So, I will write this as 0 to 0.5 fractional part of x dx. And when x lies between 0 and 1, fractional part of x is x only. So, this is 6 integral 0 to 1 x dx plus 0 to 1 by 2 x dx. What is the integral of x? X square by 2. So, 6 into x square by 2 between limits 0 and 1 plus again x square by 2 between limits 0 and 1 by 2. What is this value? Substituting upper limit, it is 1 by 2, substituting 0, it is 0. So, 6 into 1 by 2 is 3 plus here 1 by 8. So, finally answer is 25 by 8. Next question, if f of x is equal to x plus sine x, find integral pi to 2 pi f inverse x dx. If you remember, we have discussed and proved one formula, integral a to b f of x dx plus integral f of a to f of b f inverse x dx is equal to b f of b minus a f of a. Okay. So, we are going to use this formula. Here f of a and f of b are pi and 2 pi. If f of a is equal to pi, then what is the value of a? F of a is a plus sine a is equal to pi. Then you can easily observe that the value of a must be pi. And if f of b is equal to pi, 2 pi, then b plus sine b is equal to 2 pi, then the value of b should be 2 pi. b is equal to 2 pi. Now, if you apply this formula, integral a to b means pi to 2 pi f of x dx, f of x is x plus sin x dx plus f of a to f of b, that is pi to 2 pi f inverse x dx. Is equal to what? 2 pi into f of 2 pi minus pi into f of pi. Now, let us calculate this integral. Integral x is x square by 2 plus integral of sin x is minus cos x minus cos x between limits pi and 2 pi plus this is the given integral I, the asked question, is equal to 2 pi into f of 2 pi is 2 pi into 2 pi 4 pi square minus pi into pi pi square 3 pi square. Now, substituting 2 pi and pi here, 4 pi square by 2 is 2 pi square minus pi square by 2 minus, if you substitute 2 pi in cos x, cos 2 pi is 1 minus substituting pi, cos pi is minus 1. So, minus of minus 1 plus 1 is equal to plus I is equal to 3 pi square, and this is what 3 pi square by 2. So, I is equal to, this is 2 and this is 3 pi square by 2 remaining. So, 3 pi square by 2 plus 2. Okay. Next question, integral 0 to 100 integral part of tan inverse x dx. We know that the range of tan inverse x is minus pi by 2 to plus pi by 2, but when x is positive, the range of tan inverse x is 0 to pi by 2. Here 0 to 100 means it is positive interval. So, tan inverse x belongs to 0 to pi by 2. If you take the approximate value of pi by 2, it is 0 to 1.57. Now, its integral part will be 0 when it lies between 0 and 1, and integral part will be 1 when it lies between 1 and 1.5. So, we have to integrate it in two parts. We have to break this integral at 1. One is what? Tan inverse x. We have to break this integral at tan inverse x is equal to 1. If tan inverse x is equal to 1, x is equal to tan 1. So, I am going to write this as integral 0 to 100 integral part of tan inverse x dx is equal to 0 to tan 1 in this interval. Tan inverse x lies between 0 and 1 because tan inverse x is increasing function. So, when x is increases from 0 to tan 1, tan inverse x increases from 0 to 1, then its integral part is 0. Then we have to integrate from tan 1 to 100. Integral tan 1 to 100. In this interval, tan inverse x lies between 1 and 1.57. Okay. So, its integral part is 1. Integral of 0 is 0 in definite integrals, because even if you write c, difference will be c minus c 0. And what is this? Integral of 1 is x, limits tan 1 to 100. Now substituting the limits, 100 minus tan 1, this is the answer. Okay. Next question, integral 1 by e to tan x t by 1 plus t square plus 1 by e to cot x 1 by t into 1 plus t square dt. Here there is one important point to remember. Whenever the question is given as sum of two definite integrals, you do not calculate both, you calculate one of them and combine with the other. Okay. And this is one point, and another important point is whenever reciprocal numbers are present as limits, like tan x and cot x, they are reciprocal to each other. Whenever reciprocal numbers are present in the limits, immediately you have to substitute x is equal to 1 by t. Okay. You have to substitute the variable as 1 by another variable. Here the variable is t, no. So, let us substitute t is equal to 1 by z. Then dt is equal to minus 1 by z square dz. As I have told you, we need to calculate only one of them. So, I will keep the first integral as it is and I will find out this using this substitution. First integral is integral 1 by e to tan x t by 1 plus t square dt plus, in the second integral we have to calculate new limits. When you are changing the variable to z, we have to calculate the limits of z. If x is equal to 1 by e, not x, t, if t is equal to 1 by e, then what is the value of z? E is equal to 1 by e is equal to 1 by z, then z will be e. If t is equal to cot x, then z will be tan x. Okay. Now, new limits are e to tan x. Here 1 by t is z by 1 plus 1 by t square is 1 plus 1 by z square into dt is minus 1 by z square dz. Okay. Now, let us simplify the second integral. First integral as it is plus, we got minus sign inside, we can remove that minus sign by interchanging the limits of the definite integral. All of you know the property, when you interchange the limits, sign will change. So, I will write this as tan x to e, simplify this, z by 1 plus z square dz. Now, integral 1 by e to tan x t by 1 plus t square dt plus, we know that we can replace z by x or t or y, anything, without changing the function, without changing the limits, we can replace z by any other letter. Okay. So, I will replace z by t now. integral tan x to e t by 1 plus t square dt. That means this t is different and that t is different. Okay. Now, you see function is same. Here we are integrating 1 by e to tan x, then tan x to e means its sum is 1 by e to e t by 1 plus t square. Okay. So, this is equal to integral 1 by e to e t by 1 plus t square. Now, how to integrate? Derivative of 1 plus t square is 2t. So, if you multiply by 2 and divide by 2, numerator is the derivative of denominator. So, using our formula f dash x by f x, integral f dash x by f x is log mod f x. This will be half log 1 plus t square. Now, we have to substitute the limits. You substitute and simplify, you are going to get half log e square. Then you can write it as 2 log e, 1 by 2 into 2 log e. Two cancels. What is the value of log e? 1. So, sum of that integrals is 1. Next question. If f of x is equal to integral 0 to x cos power 6t dt, then f of x plus pi is equal to f of x into f of pi, f of x by f of pi, f of x minus f of pi, f of x minus f of pi, f of x plus f of pi. Now, let us take f of x plus pi. If f of x is this integral, f of x plus pi will be integral 0 to x plus pi cos power 6t dt. Now, we have to express this in terms of f of x and f of pi. So, let us write this as integral 0 to x cos power 6t dt plus integral x to x plus pi cos power 6t dt. Now, this is f of x. Plus, now recollect the property of definite integral. If f of x is a periodic function with period t, then integral a to a plus nt f of x dx is equal to n integral 0 to t f of x dx. This integral is independent of a. Here cos power 6t is a periodic function with period pi. So, take the limit as x to x plus 1 into pi. Then using that property, it will be 1 into integral 0 to pi cos power 6t dt. It is independent of x according to this property. What is this? It is f of pi. So, you will get f of x plus f of pi. So, what is the correct answer? Option D. Okay. Now, I am going to discuss some important and useful results in definite integration. If you use these results, you can save lot of time in calculation work. Integral 0 to a f of x dx is equal to half integral 0 to a f of x plus f of a minus x. It is a very simple property. When the limits are 0 and a, when I is equal to integral 0 to a f of x dx, you can replace x by a minus x. Then it becomes integral 0 to a f of a minus x dx. Then immediately what will you do? You will add the two integrals. 2I is equal to integral 0 to a f of x plus f of a minus x dx. Dividing by 2, you will get this property. It is not a property, it is just a shortcut. For example, you want integral 0 to pi by 2 root tan x by root tan x plus root cot x. Then immediately you write it as half into integral 0 to pi by 2 f of x, that is root tan x plus root tan x by root tan x plus root cot x plus f of a minus x means replace x by pi by 2 minus x. Then tan pi by 2 minus x is cot x, cot pi by 2 minus x is tan x. So, this becomes root cot x by root cot x plus root tan x dx. What is the sum? Sum is 1. So, it is 1 by 2 integral 0 to pi 1 dx. Now, calculating, this is pi by 2 now. So, finally, you will get the answer pi by 4. Next, integral 0 to a x f of x dx is equal to a by 2 integral 0 to a f of x dx if f of a minus x is equal to f of x. When the limits are 0 and a, immediately you will try that property, replacing x by a minus x. Take the given integral as I, integral 0 to a x f of x dx is I. Replacing x by a minus x, integral 0 to a minus x into f of a minus x dx. If f of a minus x is equal to f of x, then this will be equal to integral 0 to a minus x into f of x dx. Now, adding this and this, 2I is equal to integral 0 to a is common, f of x is common, and adding the remaining you will get x plus a minus x a f of x dx. So, I is equal to a by 2, a is constant, so you can write it outside, divide by 2 integral 0 to a f of x dx. Now, you can use this result as a shortcut formula and calculate the answer quickly. That means, whenever the integrand is in the form of x f of x, limits are 0 to a, you check f of a minus x. If f of a minus x is equal to f of x, immediately remove this x and multiply by a by 2. Okay. Let us see one example. Integral 0 to pi x sine square x dx. Okay. Here, in sine square x, if this is f of x, x f of x is sine square x, replacing x by pi minus x, you are getting the same function. So, immediately remove this x and multiply by upper limit by 2. So, what we will get? I is equal to pi by 2 integral 0 to pi sine square x dx. Now, to calculate the answer, since you are getting the same function by replacing x by pi minus x, we can use another property. What is that? Dividing the upper limit by 2 and multiplying the integral by 2. So, pi by 2 into multiply the integral by 2, divide the upper limit by 2. Then integral 0 to pi by 2 sine square x dx. Now 2 cancels. Again replace x by pi by 2 minus x. Whenever limits have changed, again you can try the property, whenever, as long as the limits are in the form of 0 to a. Replacing x by pi by 2 minus x, sine square x becomes cos square x. Okay. Now adding this integral and this integral, 2y is equal to pi into integral 0 to pi sine square x plus cos square x is 1 dx. Integral of 1 is x. So, pi into x between limits 0 and pi by 2. Substituting the limits and simplifying, you will get pi square by 2. This is 2i. So, I is equal to pi square by 4. Okay. Next, integral a to b f of x dx can be written as half integral a to b f of x plus f of a plus b minus x. It is similar to the first shortcut we have discussed just now. Take integral a to b f of x dx as I. According to our properties, you can replace x by a plus b minus x. Integral a to b f of a plus b minus x dx. Okay. Adding these two, we get 2i is equal to integral a to b f of x plus f of a plus b minus x. Then dividing by 2, we get this result. Okay. Let us solve one question on this. Integral 2 to 3 x square by, in the denominator you separate one x square, remaining is x square minus 10x plus 25. We can write it as either x minus 5 whole square or 5 minus x whole square. I will write it as 5 minus x whole square, denoted by I. According to the formula, we can write it as half integral 2 to 3, this same f of x plus what? F of a plus b minus x. A plus b minus x is 2 plus 3 minus x, 5 minus x. You can replace x by 5 minus x, 5 minus x whole square by 5 minus x whole square plus, here 5 minus of 5 minus x is x. So, you will get x square dx. Now, observe it, what is the sum of these two? It is 1. So, half integral 2 to 3 1 dx. If you calculate, finally you will get answer 1 by 2. Next point, integral a to b x f of x dx. We can eliminate this x and multiply by a plus b by 2. The proof is similar to the proof of integral 0 to a x f of x dx. You replace a plus x by a plus b minus x. If f of a plus b minus x is equal to f of x, then by adding the two integrals you will get this answer. Okay. One example, actually here limits must be corrected. Let us take pi by 3 to 2 pi by 3. Then a plus b minus x is, a plus b is what? Pi, pi minus x. If you replace x by pi minus x, tan square x remains same. So, we can eliminate that x and multiply by a plus b by 2. What is a plus b by 2? Pi by 2. Pi by 2 integral pi by 3 to 2 pi by 3 tan square x. Now you know how to integrate it. You can write the tan square x as secant square x minus 1 and integrate it. Okay. You finish the calculation and some more results. When there is an integral a to b where function is in terms of kx, f of kx, then what will you do? You will put kx is equal to t. Putting kx is equal to t, you will get k dx is equal to dt. Dx is equal to dt by k. Then it becomes, limits are a to b, then what are the new limits? Ka to kb will be the new limits. Integral Ka to kb f of t into dx is dt by 2, dt by k. Now we can replace t by x, then you will get this result. So instead you can avoid this procedure and remember this result. What is this result? When there is a function in terms of kx, you understand the result like this. When x is divided by k, this becomes f of x. When you want to divide x by k, you should multiply the limits by k and divide the integral by k. Okay. The same property can be understood like this. What is this? Here you want to multiply x by k. If you want to multiply x by k, we have to divide the limits by k and multiply the integral by k. Okay. Next point, integral a to b f of x plus k is equal to a plus k to b plus k f of x dx. Here you can put f x plus k is equal to t and you can easily prove it. But without you writing that substitution, you can directly apply this step. So if you want to subtract k from x, you should add k to the variable limits. If you want to subtract a constant k from the variable, you have to add the same constant to the limits. Similarly, if you want to, here suppose this is x minus k, limits will be a minus k to b minus k f of x dx. Now the combination of this and the previous result will be this. If the function is in terms of Lx plus m, then new limits will be La to La plus m to Lb plus m f of x dx. Since L is multiplying x, we have to divide by L, 1 by L into integral La to La plus m to Lb plus m f of x dx. Now let us solve one question on the above results. Integral 0 to 1 e power t by 1 plus t dt is given as a. Then what is integral b minus 1 to b e power minus t by t minus b minus 1 in terms of a and b? Let us write it. Integral b minus 1 to b e power minus t by t minus b minus 1 dt. I want the limits to be 0 to 1, then only I can write this in terms of a. So, if you want to get the limits 0 to 1, you subtract b minus 1 from the limits. If you subtract b minus 1 from the limits, limits will become 0 to 1. If you subtract b minus 1, then you should add b minus 1 to the variable. So, e power minus of t plus b minus 1 by, here also t plus b minus 1 minus b minus 1 dt. Okay. Then you will get integral 0 to 1. You can take out e power minus of b minus 1 instead of that I think let us subtract only b from the limits. If you subtract b, limits will be minus 1 to 0. This becomes e power minus of t plus b. If you subtract b from the limits, you should add b to the variable by t plus b minus b minus 1 dt. Now, from numerator you can write e power minus t into e power minus b. You can take out e power minus b. It becomes e power minus b integral minus 1 to 0 e power minus t by t minus 1, here b cancels, dt. Okay. Now, if I want to divide t by minus 1, okay, if I want to divide t by minus 1, then I should multiply the limits by minus 1 and divide the limits, divide the integral by minus 1. Then you will, what you will get, minus integral minus b, because you are dividing by minus 1. You have to multiply limits by minus 1. So, you will get 1 to 0 multiplying by minus 1. If you divide t by minus 1, it becomes e power t. This becomes minus t minus 1. Now, interchange the limits. What happens? Sign will change. Then take minus sign and make it plus. So, it becomes minus e power minus b integral 0 to 1 e power t by t plus 1. This integral is what? Given as a. So, answer is minus a e power minus b. Among the 4 options, correct answer is D. Now, let us continue solving problems. Integral 0 to 3 mod x plus, this is mod x minus 1 plus mod x minus 2. Here, first you separate the integrals. Integral 0 to 3 mod x dx plus integral 0 to 3 mod x minus 1 dx plus integral 0 to 3 mod x minus 2 dx. Okay. In this interval, x is completely positive. So, directly you can remove the modulus. In the interval 0 to 3, mod x is equal to x. And in the second integral, when x lies between 0 and 1, x minus 1 is negative. So, if you want to open the mod, you have to write it as 1 minus x. In the interval 1 to 3, x minus 1 is positive, so directly you can open the mod. So you have to separate into two integrals, 0 to 1, 1 to 3. In this interval, mod x minus 1 will be 1 minus x. In this interval, x minus 1 is positive, so it will be x minus 1 dx plus, again we have to break this integral at 2. From 0 to 2, x minus 2 is negative, so opening the mod it becomes 2 minus x. 2 to 3, x minus 2 is positive, so mod of x minus 2 is x minus 2. Integral 0 to 2, it is 2 minus x, and 2 to 3, it is x minus 2. Okay. Now let us calculate. Integral x is x square by 2, limits 0 to 3. Integral 1 minus x is x minus x square by 2 between limits 0 and 1 plus, this is x square by 2 minus x between limits 1 and 3 plus, this is 2x minus x square by 2 between limits 0 and 2 plus x square by 2 minus 2x between limits 2 and 3. Now substitute the limits, substituting 3 and 0, you will get 9 by 2. Substituting 1, you are getting 1 minus 1 by 2, 1 by 2. Substituting 0, it is 0. Next, plus substituting 3, you will get 9 by 2 minus 3, and substituting 1, minus of 1 by 2 minus of minus plus 1, plus substituting 2 here, 4 minus 2, it is 2. Substituting lower limit 0, it is 0. Next, substituting 3, you will get 9 by 2 minus 6, minus substituting 2, it will be 2 minus 4 minus 2, so it becomes plus 2. Now if you simplify it, you will get the answer 19 by 2. But this procedure is very long. I will explain another short method for this question. You know that graph of y is equal to mod x will be like this. Okay. What will be the graph of y is equal to mod x minus c? You have to shift this by c units towards right. This is 0 comma 0. You have to shift this vertex by c units towards right. Then graph of mod x minus c will come like this. What is this angle? 45 degrees. This angle is 45 degrees. Now suppose you want the integral a to b mod x minus c dx, where c lies between a and b. A is less than c, less than b. C lies between a and b. Then the line x is equal to a will be here, x is equal to b will be here. If you integrate this function from x is equal to a to x is equal to b, we know that the value of the integral will give you the area bounded by this curve and x axis, because the curve is completely above the x axis. So this integral is nothing but area of this triangle plus area of this triangle. that black shaded part is the value of this integral, because curve is completely above the x axis. Now this width is c minus a, this height is also c minus a, it is a right angled isosceles triangle. So what is the area? C minus a whole square by 2. Similarly this width is b minus c, this height is also b minus c. So this area is b minus c whole square by 2. So sum of these two areas will be given by a minus c whole square plus b minus c whole square by 2. We can write c minus a whole square or a minus c whole square, both are same. Okay. If you can remember this result, then you can solve the previous question very easily. See, this is x minus 1, now here c is 0, so 0 minus 0 whole square 0 plus 3 minus 0 whole square 9 by 2, first integral. Second integral, 0 minus 1 whole square is 1 plus 3 minus 1 whole square 4 by 2 plus 0 minus 2 whole square 4 plus 3 minus 2 whole square 1 by 2. Directly you will get the answer 19 by 2 without wasting time. Okay. So all of you remember this formula for integral of mod x minus c between a and b, but make sure that c lies between a and b. Now next question, if integral 0 to 10 f of x dx is equal to 5, find integral sigma k varies from 1 to 10, integral 0 to 1 f of k minus 1 plus x dx. Let us write it. First, I want to make this f of x, then what should I do? I have to subtract, I have to replace x by x minus k plus 1. That means I have to subtract k minus 1 from x. If I subtract k minus 1 from x, this becomes f of x. If I subtract k minus 1 from x, we have to add k minus 1 to the limits. So this is equal to sigma k varies from 1 to 10, add k minus 1 to the limits, 0 plus k minus 1, k minus 1, 1 plus k minus 1 is k. Now this becomes f of x. Okay. Now sigma means summation, so substitute k is equal to 1, 2, 3 and so on up to 10 and add the integrals. Substituting k is equal to 1, you will get integral 0 to 1 f of x dx. Substituting k is equal to 2, this becomes integral 1 to 2 f of x dx plus substitute k is equal to 3, it becomes integral 2 to 3 f of x dx and so on. Finally, putting k is equal to 10, you will get integral 9 to 10 f of x dx. Now you are integrating f of x from 0 to 1 here, 1 to 2 here, 2 to 3, 3 to 4 up to 9 to 10. What will be the sum of all these integrals? You can write it as a single integral from 0 to 10 f of x dx, and its value is given as 5. So the answer to the question is 5. The value of the sigma is 5. Next question, integral 0 to pi dx by 1 plus 2 sine square x. Here replacing x by pi minus x, it is remaining same, so no use of the property. In indefinite integration, what is the standard method to integrate 1 by a plus b sin square x? We have to multiply and divide by secant square x. So multiplying by secant square x, you will get secant square x dx by denominator is secant square x plus 2 into sin square x into secant square x is tan square x. Now secant square x is the derivative of tan x. So I will write the denominator completely in terms of tan x. You can write secant square x as 1 plus tan square x. So it will be integral 0 to pi secant square x dx by 1 plus 3 tan square x. Okay. Now we have to put tan x is equal to t. Its derivative is secant square x dx is equal to dt. So this becomes integral dt by 1 plus 3t square. Now calculate the new limits. If x is equal to 0, tan 0. If x is equal to pi, tan pi is 0. What are you getting? If the limits of the definite integral are equal, the integral is 0. But observe the function 1 by 1 plus 2 sin square x is a strictly positive function, is it not? Its graph will be completely above the x axis in any interval. Okay. When the graph is completely above the x axis, you cannot get the answer 0, you must get a positive number. That means this answer is wrong. So where is the mistake? The mistake is in this substitution. In this interval 0 to pi, tan x is not defined at pi by 2, discontinuous at pi by 2, not monotonic in 0 to pi by 2, 0 to pi. Okay. So when you want to substitute this for this interval, it is wrong. So what we do is, we have a property replacing x by pi minus x. If the function remains same, what can you do? You can divide the upper limit by 2 and multiply the integral by 2. So in the first step itself, you apply that property, you will get this, the given integral is equal to this. So the next step will be this, next step will be this. Now you check the limits. Substitution is correct now. In the interval 0 to pi by 2, tan x is a monotonically increasing function. If x is equal to 0, tan 0 is 0, lower limit is correct. If x is equal to pi by 2, tan x is not defined, tan pi by 2 is not defined. There we have to take limit. If x tends to pi by 2 from left side, limit as x tends to pi by 2 from left side means pi by 2 minus tan x is what? Infinity. If you look at the graph of tan x, it will be like this. If x tends to pi by 2 from left, tan x is tending to plus infinity. So it becomes, when x tends to pi by 2, upper limit will be infinity. Now what is the integral of 1 by 1 plus 3t square? If you write this as root 3t whole square, integral 1 by 1 plus x square is tan inverse x. So tan inverse root 3t, and then we have to divide by the inner derivative root 3. inner derivative of root 3t is root 3. Now we have to 2 is also there. Now we have to substitute limits 0 to infinity. 2 by root 3 into, substituting upper limit, tan inverse infinity tends to pi by 2 from this, just from that figure, minus tan inverse 0 is 0. So finally you will get the answer pi by root 3. Okay. Next question. Integral 0 to pi x sin x by 1 plus cos square x. If you take sin x by 1 plus cos square x as f of x, it is in the form of x f of x dx. We have a shortcut. What is that? Replacing x by pi minus x, if the function remains same, you can remove this x and multiply by upper limit by 2. You check, replacing x by pi minus x, sin pi minus x is sin x. 1 plus cos square pi minus x is 1 plus cos square x only. So we can apply that shortcut. I will write this as upper limit by 2 integral 0 to pi sin x by 1 plus cos square x. Now derivative of cos x is sin x minus sin x. So we will put cos x is equal to t. Derivative of cos x is there in numerator. Put cos x is equal to t. Then minus sin x dx is equal to dt. Then it will be pi by 2 into integral minus dt by 1 plus t square. What are the limits? If x is 0, t is 1. If x is pi, cos pi is minus 1. Okay. Now pi by 2 into minus pi by 2 into integral 1 by 1 plus t square is tan inverse t. Between limits 1 and minus 1. Substituting minus 1, tan inverse minus 1 is minus pi by 4, minus substituting 1, tan inverse 1 is pi by 4. If you simplify it, you will get the answer pi square by 4. Okay. Next question. Integral 0 to 1 log 1 plus x by 1 plus x square. Put x is equal to tan theta. In indefinite integration, we have discussed one method, standard trigonometric substitution. Whenever the integrand is in terms of a square plus x square, we have to put x is equal to a tan theta. So using that trigonometric substitution, I am putting x is equal to tan theta. Then dx is equal to secant square theta d theta. Then the integral will be log 1 plus tan theta by 1 plus tan square theta is secant square theta into dx is secant square theta. What will be the new limits? If x is 0, theta is 0. If x is 1, if tan theta is 1, then theta is equal to pi by 4. After cancelling secant square theta, it is the same question which we solved in the previous class, if you remember. What is the method? Replacing theta by pi by 4 minus theta, you will get integral 0 to pi by 4 log of 1 plus 1 minus tan theta by 1 plus tan theta, which is equal to 2 by 1 plus tan theta. Then adding these two, if you remember, we got the answer as pi by 8 log 2. So, refer the previous class. Okay. Next question. Integral minus 4 to minus 5 e power x plus 5 whole square dx plus 3 integral 1 by 3 to 2 by 3 e power 9 into x minus 1 by 3 whole square. Let us write it here. E power, if I take 3 inside, 9 inside, it becomes 3. Then it becomes 3x minus 1 whole square dx. Is it not? Now, as we discussed earlier, if the question is a sum of two integrals, no need to calculate both. You calculate only one of them, usually the second. Then combine with first. So, I am going to calculate only second. In the second, since the function is in terms of 3x, I will use f of kx property, f of kx formula. Okay. So, if x is to be divided by 3, what should we do? We should multiply the limits by 3 and divide the integral by 3. Write the first integral as it is. What should you do? If you want to divide x by 3 to make it x, if you want to write as x minus 1 whole square, I have divided x by 3, then I should multiply the limits by 3, so limits will be 1 to 2. Divide the integral by 3, then this 3 will go, dx. Now, if we want to combine this and this, limit should be same, no? How can you get limits minus 4 to minus 5? You have to subtract 5 from the limits, 5 or 6. Okay, subtract 6, so that this becomes, it should become x plus 5, no? Replace x by x plus 6, replacing x by x plus 6. That means you are adding 6 to x. If you add 6 to x, you have to subtract 6 from the limits. So, this becomes minus 5, this becomes minus 4, it becomes x plus 5 whole square. First is minus 4 to minus 5 e power x plus 5 whole square. Now, if you interchange the limits, what happens? Sign will change. That means this is negative of this. So, these two will cancel. You will get the answer 0. Okay. Next question. Integral minus 2 to pi sine square x by integral part of x by pi plus 1 by 2. First I will write this as minus 2 to 2 one integral, 2 to pi another integral. Plus 2 to pi Okay. Now call this as I1, this as I2. I will calculate I1 and I2 separately. I1 is equal to, now limits are minus 2 and plus 2. When the limits are minus a and plus a, we should check whether the function is even or odd. Numerator is even function, sine square of minus x is sine square x, but denominator is greatest integer function, which is neither even nor odd. So the whole function is neither even nor odd. Then I told one point in the previous class, if you remember, whenever the limits are minus a and plus a and function is neither even nor odd, what should you do? We should apply another property, that is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. You have to apply this property. Here what are a and b? Minus 2 and plus 2. A plus b minus x means minus x. If you replace x by minus x, it remains same. So I will write it as minus 2 to 2 sine square of minus x is sine square x by denominator is integral part of minus x by pi plus 1 by 2 dx. Now integral part of x plus integral part of minus x will be minus 1 if x is a non-integer. If x is not an integer, it is 0 if x is an integer. So only at finite number of points at integral values it is 0, otherwise for all other values continuously it is minus 1. So I will ignore this definition because it is happening only at finite numbers, at finite points. So its uniform definition is minus 1. So I will write this denominator as integral minus 2 to 2 sine square x by integral part of minus x is minus 1 minus integral part of x now. So minus integral part of x by pi minus 1 I will write plus 1 by 2. Now denominator is minus integral part of x by pi minus 1 by 2. If you take out minus sign, what is this? This is I1, so this is minus I1. If I1 is equal to minus I1, then what is the value of I1? 0. Now if you take I2, if x lies between 2 and pi, x by pi lies between 2 by pi and 1. In this interval, what is the integral part of x by pi? It is 0. So it will be sine square x by 1 by 2 means 2 sine square x, because this integral part is 0. Now you know how to calculate this integral. Write 2 sine square x as 1 minus cos 2x and calculate the answer. Okay. So you finish the calculation. With this I am going to close the session for today.